Bonjour, je m'appelle Uri, et je parle pas français. Thank you. So we'll do the session in English. We also have no slides. We are going to have some cool live coding. And today I'm going to show you what is possible to do with just the web browser, how we can get out of the boundaries of the web browser and interface with the real physical world. How many of you are web developers? Almost everyone. So I'm in the right place. And I have two variations of the demo. One of them is using Angular, and the other one is using just vanilla JS. So how many Angular developers do we have in the audience? Quite a few. So good news for you. I actually got here a few Angular stickers. So if you want them, just catch me later. I will give. There is enough for everybody. So I see there are many Angular developers here. We will try to go with the Angular version. Most of it is not specific to Angular, so no worries. Before we get into the real coding stuff, a few words about myself. I'm a Google developer expert, which means I write about technology, mostly web and Internet of Things related technology. I go to conferences. I'm so happy to be here with you in Nantes, my first time here. And I also blog. You can find a lot of my blog posts and hardware projects here on my homepage. This is my latest post about the same subject as the talk, so you can check it out later. Apart from all the technology stuff, I also dance salsa. Are there any salsa dancers in the audience? You. Perfect. So. Perfect. So if you want, I can teach you how to dance later. And a few years ago, I went to Peru, and I got a pan flute. I brought it here with me today. I'll play you something real quick to see if you recognize it. So this is the pan flute. It is the real thing from Peru. Restart. And for the guys, if you actually read this text, you probably spotted that I work for BlackBerry. Yes, they still exist. And with that, let's get the fun begin. So what are we going to do today? I've prepared a list of links about technology called Web Bluetooth. We are going to speak about it real soon. And don't worry about this list. I will share it on my Twitter in a few moments. You can find it here on the top of my screen at Uri Shaked. And during this talk, if you have any questions, you can also mention me on Twitter. I will be checking this mention list a few times during the talk. So if you do mention me and I see your question, I will answer it during the talk or after the talk privately. So we are going to use a technology called Web Bluetooth. A few of you might have been here in this conference last year and watched the session by Francois and Jean-Francois, I think, about Web Bluetooth. Somebody attended it? A few. Really a few. So they showed you a new technology called Web Bluetooth. Today, 1U4 I'm here to show you what we can do with that technology. And Web Bluetooth, how many of you have heard of it? OK, so I'll tell you about it. Web Bluetooth is a technology that allows the web browser to connect with physical devices using Bluetooth Low Energy. And we are not going to go into the deep details of how Web Bluetooth works. I have another talk about that. You can find it on the list of links, Getting Physical with Web Bluetooth, the English version. And I will share it on Twitter in a moment, the list. But there are a few important things for you to know about Web Bluetooth. The most important question that I always get asked is, can I really use it on my device? So the answer is yes. Web Bluetooth already works today on Chrome, on Android, on Linux, on Mac, Chromebook. I created a polyfill for Windows 10, so also on Windows 10, hopefully it will make it into Edge at some point. And have you noticed any operating system missing from the list? iOS, right. So we are still waiting for Apple to build it for iOS. In the meanwhile, there is an app in the App Store that simulates it. So there is a spatial web Bluetooth-enabled browser. But except for iOS, it's pretty much deployed. If you have a Mac or Android, you can play with it without installing anything. It just works, which is awesome. So what are we going to do with this technology? Today I'm going to show you a consumer device called Muse that lets you read brain activity. It's an EEG device which measures the electronic potentials on your scalp and translates them into data that we are going to read and manipulate in our application. So first of all, let me get started by showing you a small app I built with Angular. It's called the Muse EEG Explorer. And this app is what I built in order to learn how Muse works and to learn how to read the data. And without further talking, let me show you the Muse device that we will be using today. So, my Muse, it has a nice package. And it's a very small and lightweight device, as you can see. And it has Bluetooth, so when I switch it on, it's actually connectable through Bluetooth. And next thing, I'm going to put it on my head and connect to it from the Angular app. Angular app, please connect with the Muse. Now, this is the most risky part of the demo. I hope it will work. As you have seen this small pop-up, it's part of Web Bluetooth. So you can see my brainwaves live. And as you can see, there is no much activity there. Yeah, I can see it's not sitting very well. Let's see. OK. So before we go into what all those lines means, let me tell you, first of all, what are those funky names. So TP9 and TP10 are two electrodes connected to my ears. So watch what happens when I touch my left ear. You can see the big jump on TP9. And then TP10 is the one that is next to my right ear. And same goes with AF8 and AF7. They are more interesting. As we'll see in a moment, they are just above my eyes. So remember, the two ones in the middle are the more interesting electrodes. And apart from that, the Muse also has a nice feature. It has an accelerometer and gyroscope, so it can know my head's orientation. I created a small WebGL visualization, so you can see this guy nods. No. Oh, I do know, and it does yes. He's crazy. So let's get back to AF7 and AF8. AF7 above my left eye. Now, see what happens when I blink my left eye. Did you see the big spike in the graph? Now, let's do the same with my right eye. So, as you can see, this device is actually able to pick up whenever I blink my eyes on AF7 and AF8. It's pretty clear in the graph. But the graphs are quite nice, but they are getting boring after a few seconds. Like you just watch graph and see all those funky lines going up and down. And today we are going to use RxJS to process this data and build our own application that will detect those blinks, those jumps in the graphs that you have seen. How many of you have used RxJS? OK, so a few words about RxJS before we dive into the code. RxJS, also known as Reactive Extensions for JavaScript, I think it's a project started at Microsoft. By the way, if you notice any unusual activity while I speak, let me know. So It's basically a library that allows you to take streams of events, like you have a lot of events coming in, and you want to process them, to manipulate them. And it's very good at that. And in this case, we are going to use RxJS to manipulate the stream of EEG data, of the brainwave information that is coming from the headset, and make something meaningful out of it. Before we dive into the code, I want to do something that I promised to you at the beginning of the talk. Maintenant, je vais faire un tweet. So yeah, you can find the links on Twitter. And apparently when I switch screens, I also switch to French. I didn't know that's how it works. And now we are going to disconnect from the Muse and connect to the code. Yeah, we said we'll try to do it with Angular. So I already prepared a new Angular project using the Angular CLI and GNU Brain. Let's open it up with Visual Studio Code. Any Visual Studio Code users here? That's nice. So there are a few guys from Microsoft here. You should be proud. People are using your product. That's amazing. OK, I'm going to npm start. That will, you know what? First of all, let me, yes, I'm using Yarn, install the Muse.js. That's a library that allows me to use web Bluetooth to connect with this device. Yarn add, yes. By the way, we are doing live coding, and you are also part of it. So if I do any mistakes, just tell me, and we'll make it work together. Yeah, I didn't plan for the Wi-Fi here, which is kind of flaky, but it worked. Let me run npm start. This should open in about a few seconds after running Webpack, the initial, the starting page of an Angular application. And meanwhile, while it works, let's open the app component, which is the basically the main thing that we see when we start the app. We should see it in a moment in the web browser. Yes, Webpack, please do your things. The guy who created Webpack, or who maintains Webpack, also works from Microsoft now. I don't know why I have to say it. OK, I think it just finished. So this is the Hello World app of Angular. You see they also put the Angular stickers in the app. And the next thing we're going to do is just delete all of this and put there, hello, DevFest Nantes. And we will also have a small connect button that we'll call the connect method. I'm doing Angular, so it should be click, connect. And we'll use the very creative name, connect. Very creative name. And now we are going to implement this connect method. For that, I'm going to import the Muse.js. There is a class called Muse Client, and I'm going to import it and use it. Muse.js is actually a small library, about 150 lines of code, that does all the web Bluetooth API handling for you. So instead of having to worry about all the services and characteristics, which are the ways web Bluetooth Low Energy works, you just get the data and do fun stuff with it. If you want, you can see the source code in the list of links that I shared. And I'm going to create a new instance of it, new Muse client. And the next thing I'm going to do, I'm going to call the connect method to connect to my Muse. Now, this.client. Now, you might notice that this connect method returns a promise. How many of you are familiar with promises? Very well-educated audience. I like that. So we're going to use a new feature of ECMAScript 2000 whatever called async await. For those who are not familiar, await is simply syntactic sugar that replaces then. So instead of doing then after each promise, I just await. And the next line will be executed once this promise resolved. And after connecting, I want to start receiving data. So this is also a promise, so I'll also wait for it. And once we are connected and receiving data, I want to console log connected. So we will actually know that we managed to connect. And now the interesting part, we are going to subscribe to the EEG data. This.client, I love TypeScript, another invention from Microsoft. Subscribe. And basically, the subscribe method takes an observable, which is the thing that RxJS works with. So this is an observable, as you can see. And it lets us define a method that will run whenever there is new data coming in. In this case, whenever there is a new EEG data coming from this headset. So we are going to run this code in a moment and console log all the values, so you'll have some idea how it looks like. So this is ready, I guess. Let's go back to our app, open the console. By the way, if the font is too small, just let me know. So we hit connect. We got this web Bluetooth dialog asking us which device we want to pair with. We are going to pair with the Muse. And if everything works well, we will get the word connected down here. Thank you for the clapping. That was fun. Yeah. In this case, we just find out that it switches itself off because I talk too much. And now we'll try again. Let's clear the console, click on connect. Now I'm going to make a small prayer to the God of live demos. Please do work now. Connect. It did. Thank you. So what do we see here? We see here a lot of objects. Each object has two interesting parts. Let me make the font larger, first of all, so you can see it. We have electrode. So you remember we had two electrodes next to the ears and two above the eyes. So we have the electrode, which tells us which electrode sent us this data. And we have an array with 12 integers. These integers are the data readings, the voltage that this electrode sensed. So for each incoming piece of data, they actually send us 12 samples in order to make more efficient use of the limited bandwidth of Bluetooth. I'm going to copy this object, so we'll have it as a reference, just so we remember what it looks like. So the timestamp is not important. It just tells us when the data was sent from the device, but we are not going to use it for now. And the two important parts are electrode and samples. And the first thing we want to do with all this data that we are constantly getting from the EEG headband is to filter it. We don't want all the data. We just want the data for, let's say, the left eye. So if you have a good memory, you may remember that it's called AF7. So we are going to filter the observable, and we are going to say this. We want to take all the values where value.electrode equals left eye. And then let's define left eye. I have a small array with all the names of the electrodes, and I want the index of AF7. That's the left eye. So basically, I have here the index of the left eye electrode, and then I filter my observable, so it will only pass through events that are related to the left eye. Now I have a stream of events that look like this, but only for the left eye. And the next thing I want to do, I have this this big samples array with 12 values. And what we are actually interested in is finding those peaks in the graph that happen when I blink. So it doesn't really matter what the values are. I just want to see if they crossed a certain threshold. And for that, I'm going to take the maximum value out of each 12 values, because I don't care about the values. I just care whether they got into a certain number or not. And we will use map for that. So I'm going to call map, take the value, and say value.samples. Now I want the maximum of this, and you probably know math.max. But math.max doesn't take an array. It takes several arguments and returns the maximum. So we could write values.samples bracket 0, bracket 1, etc., like each of the individual array items. Or we can use another cool feature of the new JavaScript, which is the spread operator. Basically the equivalent of writing samples place 0, samples place 1. And one last thing, if you notice, some of those values are actually in this case, all of the values are negative. And I'm not interested in whether the value was negative or not. I'm not interested whether the peak was up or down. I just want to know if it crossed a certain value. So I will take the absolute value before I calculate the max. So yeah, so first of all, I take the absolute value of all those 12 samples, then I find the maximum, or JavaScript finds it for me, and then somebody's unhappy. Property does not exist. Maybe I have to import RxJS so everything will exist. Yes. Don't try it at home. There is a better way to use RxJS, but in live demos, that's enough. So OK, right now, I am already at a point where I get the input from the EEG. I filter the left eye. I just take the maximum value out of each reading. And now all I need to do is to set a threshold, like the number that I want to filter. And in this case, we'll just go with 500 and hope that it will work. So we'll say filter. Let's call it sample now. Sample greater than 500. So basically, this is all we probably need to do to get something working. Let's try it now. This time, I'm going to be smarter and see. Yes, it's still on. And let's connect with this device. And if everything works well, we will actually see numbers whenever I blink, and only when I blink. But first, OK, it's connected. Are you ready for me blinking? Yes, it works. I know why you are impressed, because you are web developers, but real users don't see the console. We'll address that in a moment. First of all, I want you to notice that we have a lot of values whenever I blink, like you see 2 or 5 values whenever I blink, because like it goes high and then down, so it detects multiple peaks, because we take each 12 samples and just check if the maximum is greater than 500. So for that, I'm going to use some RxJS sorcery. I will go over it pretty quickly, and if you need more information, you can find it on my blog post. So what we are going to do, we are going to use an operator called switchMap, and this is where the real power of RxJS comes. And I'm going to return a new observable. So switchMap discards the values that it gets and returns a new observable. And I'm going to return the value true. And then after 300 milliseconds, I'm going to return the value false. Now, I want to take those two observable and merge them together, so I'll call observable.merge. And now it should be happy. It is not happy. Oh, I need to import observable from RxJS. And now it's happy. OK, and now I'll explain real quick what I did. Let's also add a word blink here. So basically, what I did here, I mapped all the incoming values to true. So whenever we have a new reading, we will get a value true. Then 300 milliseconds after it, we'll get a false. So this actually creates sort of state machine that gives me information whether I'm currently blinking or stop blinking, true and false. But then the switchMap trick happens. Basically, whenever there is a new value coming, switchMap will ignore everything we have previously created. So if I just had a value, I emitted the value true, and then I get another value, everything that was created, including this timer that will send false, will be discarded. So whenever I get a new value, all the old false values are discarded. They are thrown away. So eventually what will happen, I will just get true, 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 true. And after 300 milliseconds without activities, I will get false. Let's even improve it a little bit more, because right now I get true, 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 false, true, 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 false. And I don't care about all those truths. I only want to get the first one, and then after some time, false, after I haven't received any values bigger than 500. So RxJS got us covered with distinct until changed, which basically means don't emit the same value twice. If you have seen the same value as before, just discard it and wait for a new value. And with that, we probably have our demo ready, but still not very useful for the user. Let's just do a quick check to see if it works still. And connect, please, will you? Did it oh, switch map is not a function. Any idea why is that? Let's try to import it. RxJS, add operator, switch map. It should have worked, but you never know. Let's try that again. At least this time it's not a device, it's my code. So I feel guilty this time. Let's see if this works. If not, we can always copy-paste from the solution. Why doesn't it work? Type error, distinct until change. OK, so it's going to actually force me to import every single one. Or I can just import RxJS. I will just import every single one, because we have no distinct until changed is undefined. Okay, let's try this thing, and if it doesn't work, we'll just get rid of distinct until change. Will it work? Excitement. Reloading, connect, muse. Well, it's good that we tested the code before the final demo. Now, yeah, switch map is not a function. So let's go back. I have no idea. It worked before. Let's just remove the distinct until change. It won't affect anything for now, except my affection for RxJS. OK, connect. So now we'll get, actually, instead of, you know what, let's leave it like that. Now it will connect and it will work. I know that it will work this time. There is no other place it can fail. Now, as you can see, whenever I blink, I get a few trues and false, a few times true and false, and a few times true and false. So basically, we turned a stream of numbers into very simple true and false. And now the fun part begins. We have this in console, and we want to visualize it. So up to now, I have only written one Angular line. Everything was just JavaScript. Now we are going to hook it into Angular. Oh, I'm not blinking. Now I am. OK. Instead of subscribing to this observable, we are going to save it to a variable. Let's call it, let's get rid of this title. Let's call it blinks, observable of Boolean. And then we can say this.blinks equals whatever we did before. Now, this is all the JavaScript code we need to write for this. Now we are going to move to the template. And I'm going to put an icon of an eye. Let me quickly Google that. Did you know that there is an emoji for one eye? There is. And let's give it a class one eye. And then I want you to help me with that. Component CSS. What size should we give the eye? Silence. 42 what? Pixels, OK. OK, you are not adventurous, so somebody would say 42 EM. Yeah, OK, let's do 42 EM. Thank you. Thank you so much. OK, 42 EM is apparently very big. But OK, I will go with that. We'll have less console space and less connect space. And then the last thing we want to do, I actually want to say this thing. Class.blinking equals blinks pipe async. How many of you are familiar with the async pipe? Not many, so it's good that you are here. I see those guys from Microsoft. They raised their hand for everything I say. That's interesting. Anyway, so basically what async does, it listens for all the values of the observable. In this case, this will be either true or false. And then it takes the value that was emitted and updates this expression according to the value. It runs the change detection and acts accordingly. So in this case, it will enable or add or remove the blinking CSS class whenever it gets either true or false from the observable. So before we just subscribed to the observable and pointed it to console, and now async does the same, but instead of printing it to console, it will toggle the blinking class. Let's create it now. When we blink, what color do we want the eye to have? Pink, blue, white? You want it to disappear? OK. Ooh, my battery is running low. I will better get some power. Is it better now? I think it's charging. 5%. OK. So you wanted it to go. You wanted it to go white. I think that's not a very good idea. It's not very smart to make it disappear. So let's make it rouge. Oh, it's not a CSS color? OK, red, whatever. OK. So now, if everything is well tuned with the stars in the galaxy today, I will connect. And this very huge eye will turn red when I blink. Let's see if it works. Connected. I'm blinking. Nothing yet. Let's see if the class gets added. I should have left some console. Oh, I didn't save the file. You could have told me that. Oh, thank you. You could have listened to the audience. OK. Thank you for that. OK, we are going to connect. And it's connected. And now I'm going to blink. And it works. Thank you for the 42 EM guy. Now, I see we still have some time left, so I'm going to show you one other cool demo with Web Bluetooth. We're going to take this code and connect it to another device. So whenever I blink, I will control another device. And that device is a smart light bulb powered by Web Bluetooth. I mean, it's powered by Bluetooth, but we are going to use Web Bluetooth to control it. And we are going to use a very spatial coding development methodology. It's called SOAD, which stands for Stack Overflow Oriented Design. Basically, it means we are going to copy and paste the code and hope that it will work. OK, so for that, I will add another button. Click. Let's call it Connect Bulb. Connect Bulb. And let's even get more creative and look for bulb emoji. Yeah, bulb emoji. OK, it even works here. OK, so we have the button. And now for the connect bulb method, I'm going to go to one of my blog posts. It's called Start Building with Web Bluetooth and Progressive Web Apps. And it basically explains all the things you need to do in order to write for Web Bluetooth. And we are not going to go over it. This is a cool drawing done by my sister for my blog, so all the credit goes to her. We are just going to copy this code snippet that will connect with the bulb. You can see here, oh, don't use vard, use const. You can see here there are a lot of strange numbers, and they are all explained in the post. They are basically things that the Chinese manufacturer that created this bulb decided on. I have no idea how he got those numbers. And then we are going to change one thing. Instead of writing to it directly when we connect, we are actually going to do something really horrible and create some global variable. Let car, let's call it let car. And then we can say let car equal characteristic. So you don't really know web Bluetooth, but basically characteristics in Bluetooth are variables we can write to or read from. So we'll write to this characteristic to set the color of the bulb. And then the next thing we are going to do is copy paste even more code. There is this set color method, so we are going to copy paste it here, and we will change this to const, so tslint will be happy. And then we just send it to letCar.writeValue data. So basically now we have this set color method, and if everything works really well, let's also add a console log here. Console log, don't console assert me. Connected to bulb. Yes. So if everything goes well, once we click on the second connect button, we'll connect with this bulb. And then we can use the setColor method to change the color of the bulb. So we are going to subscribe to this.blinks again. And this time, remember, value is either true or false. And this time, we are going to say this. If, let's first of all console log blink value. And then we say, if value, this.setColor, give me a color, please. You always start with pink, so let's do it pink. What's the RGB for pink? OK, so anybody wants to give me an RGB value? FFF? No, that would be white. That would be boring. OK, I will try to do it pink for you. Let's try with F, 80. Let's do it pink purplish. BA, whatever. And then otherwise, this set color 0, 0, 0, which is black, right? So I'm going to save this, and this is the second time I try it in my life. I hope it will work better than the first time. So now we have two buttons, connect and connect bulb. Let's start with connect that we are already familiar with, and say it's connected. Yes. Now let's go with connect, just unit testing. Let's connect with the bulb. So now the web page is connected both to the headset and the bulb. And when I blink, I do have an error. Can't read property. Let's try that again, maybe because I blinked before I connected to the bulb. Connect to bulb. Now I will connect with the brain. Thank you for that, by the way. And I'm going to blink. Do you like that pink? So this is me using a web browser to connect my brain into a smart light bulb. And for those on the back, works quite well. Now, let's see if I have any questions. Oh, thank you. Nice demo. I'm going to like this one. Thank you, everybody. Wow, a video. I'm going to, OK, it's really a short one. You got my like anyway. Yeah, where did my app go? OK. So with that, I want to conclude. I refresh the page. I close the muse. And we have seen what can be done today on the web. I think this is really exciting. We are no longer limited to the screen of the computer, the keyboard, and the mouse. We can connect with anything. It could be a brain, it could be smart bulbs, it could be heart rate monitors, and I have a bunch of other demos. If you want to see a few of them, I built a small fidget spinner that you can connect to with web Bluetooth and control, so just catch me later. And we as web developers have now a lot of power in our hands. It wasn't possible until a few months ago to do those things with just a browser. Now it is. And I think we can use these kind of technologies, like the Muse EEG headset, to build very powerful interfaces that can assist people, perhaps disabled people, give them a new way to communicate with the web and with our content. Or maybe for gaming, give us a new way to make the games more engaging and fun. So I hope today, all of you, when you go home, you will start thinking, what can we build with web Bluetooth and this technology? Thank you. All right. I want to leave some time for questions. There were no questions on Twitter, but if you do have one, yes. How much does it cost? Yeah. No need for the mic. I will just repeat the question. How much does it cost? That's a very good question. It's actually not very expensive. Some people would expect this to be $1,000 or so, which was the case for EEG headsets until a few years ago. But this device is only $250, including shipping, so it's even cheaper than your smartphone. So definitely, it's not cheap, but it's definitely affordable. Thank you for asking. Anybody else with a question? Not related to pricing? Yes? Sorry? What about security? I got you first. About security. So security with Bluetooth is a painful subject. As you have seen, everybody can connect to the Muse. There is no protection and can read my brainwaves. Right now, there is no much danger in that, but as research advances, and at some point, it might be possible to read more than just blinks. Actually, it is right now. I'll tell you about it in a second. Or anybody can connect to this bulb. It's not secured and control it. So security is up to the devices to implement. Most of the Bluetooth low energy devices, such as those ones, don't implement any kind of security, which is kind of sad. But there are also more high-end devices, like this bulb costs $10. There are bulbs that cost more, and they have security mechanisms built in. So you get what you pay for, basically. I promise to you, I will tell you in a nutshell what else we can do with the Muse. So I'm in touch with several researchers that use it for research. And a few things you can already do with the Muse. One of them is to detect whether the person has recognized something he's looking for. For example, if you show me a set of photos and then I see a photo I'm interested in, let's say I'm searching for something and I see it, you will be able to pick up a very strong signal at this part, at the top of my head, after about 300 milliseconds. So if you know when I saw the photo and you add 300 milliseconds on the top of that, and you observe that signal, you can be pretty sure that I found something that I was looking for. So this is very useful in creating new interfaces. Instead of waiting for the user to confirm or not, you can get a very good intuition whether they like it or not just by reading their brain. There are many other things. This is, by the way, if you want to Google it, it's called P300. Just Google it. You will find Wikipedia entry on this signal. And there are many other signals that you can use to learn if I have recognized a face or part of face. This also generates a very strong signal in a specific part of the brain. So there are many more research we can do and find other ways to get information out of this device. But right now, with just like, I don't know, it was like 30 lines of code, I think, something like that. Yeah, including the bulb, it was 70. But without the bulb, it's like 30 lines of code. We managed to detect blinks pretty accurately in just 10 minutes. So imagine what we could do if we had some machine learning or some statistical models to make it a little bit more sophisticated. Any more questions? Yes?
Instead of just reading from your mind to the browser, is it possible to push some info from the browser so you're not using the
I always get asked that, whether instead of reading data from my brain, I can also write. Fortunately, relating to your question about security, it's not possible. Otherwise, I would be very worried wearing this. There is some research about devices that let you, I won't say write to the brain, but manipulate the brain. One of them is called Never mind. I will tell you later. Better I won't tell you. And it basically runs a current through your brain. And some people claim it helps to improve concentration and make you a superhuman while doing it. I haven't tried it. I do care about my brain, so I don't want currents running through it. It's called TDCS, transcorneal direct current stimulation. If you want to torture your brain, just Google it. Let's see if we have time for more. I think we have time for one more question.
No, we have not.
No?
No.
OK,
Sorry.
so thank you very much. And catch me for the Angulars.